Hello and a warm welcome to my presentation. My name is Ronald and I'm responsible as Business Manager Automotive and Transportation also for some new technologies like the exciting E3.Connectivity Browser, which I would like to introduce in this presentation today. But before we start, a short reminder. Immediately following this broadcast, I will be opening a live breakout session where everyone can join for question and answer and where we could discuss this topic in more further details. So today it's about making digital connectivity visible by the use of the E3.Connectivity Browser. First we will look on the use cases for this kind of application, then where the data are coming from regarding the sources. We are looking on the implementations which are available, which platforms are supported, and finally we are talking about how to share data, how to share digital views. Let's start with the use cases, and for this I use an example here. Maybe most of us have forgotten about this in the meantime. It's a map issue, and around about 30 years ago it was normal that you had this kind of maps in your car, and when then visiting a foreign city you had to find the right maps, search in the document for the right street you're looking for, and then you find out that in reality the streets have been changing and your map is outdated. But this is past. This was like we had it in the 90s. Today we have a different kind of application. We have an electronic application like a Google Maps. So it's a digital app running on an electronic device at the front end. And in the background, of course, there is a server farm, having all the digital data, having data model, and providing this as an information server over the cloud. And for the connectivity browser, we have a very similar situation. Here we have also a server in the background. Okay, our server may be a little bit smaller, maybe even a Raspberry working like in my example here. But the important thing is that we also have a digital data model here in the server, which has all the basic information for the connectivity stored. And we have a front end running on an electronic device, which is algorithm driven, creating the visualization of this digital data in a way the end user wants to see. The base is the connectivity data model, and for this we use this small example here, just 3 connectors and a few wires in between. And to describe this connectivity as a data model, of course we could use this way. Okay, it's not a digital data model, even it describes this connectivity. Maybe for this small example even sufficient. But for a digital data model, of course, we need to have a real data description, a dedicated description of all artifacts like the wires, like the pin cavities, connectors, etc. And we need to store on a digital way all the relations in between. This data model could be an SQL, could be an XML, or here in this other example here, just an Excel list. This Excel list is describing exactly the connectivity data model for this few wires here. We have always the wire, the from, and the to information. In addition, of course, then attributes describing more details. For the from and to, we have over the level cavity, connector, and component. So based on this digital data model here on the Excel list, algorithm driven generation of this data creates now this visualization. The visualization here with these 3 connectors and having the components in the background. So maybe you will say this is not extremely complicated, this is quite simple. I agree, for this small example, yes, it's very simple to do so. However, there are more complex connectivity data models in the real world, here like this example with a car, more than 3,000 wires. And this data model can be used here for the automatic generation and create a connectivity visualization just within a second. Of course, don't get me wrong, here it's not the purpose of this tool to create schematic visualizations with 3,000 wires on one sheet, one visualization. Just other way around, it's a strength of this tool to visualize specific Like here, if we want to see the connectivity around this component, then only see this wires around. Coming to the data source, the most important data source for this process, of course, is the E3 series schematics. There we define all this connectivity information, including the attributes, exporting a digital data model, and this can be used then, for example, in the service field application to visualize here based on a diagnostic input that this amplifier is broken. So this is an important process which many of our customers are using. Another source system we are using here is a wiring system lab. Wiring system lab for automotive industry has an integrated exporter here for this data format. It could also be a use case that we have data from partners, we have data from legacy systems in any kind of format. All this kind of connection list, wire list in this format can also be used to visualize here with the connectivity browser in the schematic form. So the format is secondary as long as it's a structured from to wire list. Of course, other formats like CSV, ASCII, whatever would be possible. Having a look at the platforms which are supported, so we have general two worlds. We have the Windows world, where we have the desktop solutions, and we are also supporting with this technology the cloud world. That means running from the end user point of view and the web browsers. On the Windows world, there are different applications available out of the box. One is a plug-in inside E3. There's also a plug-in inside the E3 harness analyzer, which helps us to visualize here the harness data, maybe based on a KVL directly in the tool. Here's an application example also on Windows for the cabinet technology in the machinery industry, combination between the 3D visualization of the cabinet and the related schematic. Having a look at the cloud technology, we are supporting different servers. I think in many use cases it's an Apache server running on a Linux platform. On the front end side, we are supporting the different web browsers which are on the market, starting here with Chrome or any of the others. It should be one of the latest versions of this web browsers, of course, but there are no specific requirements. A specific use case in this area is a service field, cloud-based service application. That means the OEM is storing his connectivity information in a digital form here on his server, maybe combined with his diagnostic system directly, and on the front end side in the repair center, then the technician has direct access to this data in the link with the diagnostic system, and if the diagnostic system finds out that a specific component is broken, he gets this visualization of the connectivity exactly for the car or vehicle he's repairing here in the context of the diagnostic visualized. Question often asked in the recent weeks here about tablet support. Yes, we are supporting tablets, including the gestures for zooming, panning, etc. In the meantime, we are not only supporting the Windows tablets. In the meantime, we also have support for the iOS world. That means here, like you see, an iPad Pro, normal iPad, or here all the iPhones. There's also a technology called a web app, which is supported, and this enables then a fully practical use here of this kind of devices. Okay, the iPhone is a little bit small, at least for my fingers, but on the tablet it really works perfect. Same to iOS is also Android. Also here we have the support of the tablets as well of the mobiles. Coming to a point, sharing information. And sharing information in a digital world is a specific challenge, because digital visualization gives new ways to explore, to browse the information, and this of course is then an issue for sharing this viewpoints, and there's always the question degree of recognition. Sounds strange, so I want to explain a little bit what I'm talking about. Having looked to our old example with the maps, as long we had the situation that we had real documents in the map area, of course, if both users looking to the same document, then they also have the same view, they have the same exactly the same information what they see. Being now in the digital world, in the Google Maps world, it's a little bit more challenging because they have different viewpoints, and this I want to explain here with a small simulation here. So I have two users, both users look to Paris, both users use Google Maps, and they're both searching here for a location, Arc of the Triumph, for example. So both find it, maybe both are using Street View, and both see something here, and they can browse around according to the functionality of the tool. So both are at the Arc de Triomphe, but they are flexible in their viewpoints. At the end of the day, they maybe look in a different direction. That's no problem. There's only a problem if now the users want to share the information, maybe by phone, and talk about a car they see, and maybe they see a different car in their viewpoint. So how is the solution? How the solution Google is providing? It's quite simple. It's a solution called permanent links. So I'm sharing the link from one view to the other, maybe by email or whatever, and entering the same complete URL here in the browser. I see not only the same data model, I also have the same viewpoint. So, and this is of course not a picture, it's still an active view which can be modified then on the target system. So now both have exactly the same view, independent here on their devices. So that's the way how Google solved it. Coming back to our application, in our world, of course, we have also this dynamic view, and we are starting with a static module view, for example, for a module PF, and both see the same thing, of course, at the beginning. So that's a little bit better than what we have on Google. However, we also have the chance, or the user has the chance to do modifications. So for example, my user A was adding here some content. The user B was changing the layout 90 degrees. He changed the color coding here and whatever here. And after a while, even both are looking to exactly the same content. They have a different viewpoint. And if they call each other now and talk about it on the upper right corner, they maybe get a misunderstanding. So that's a challenge what we have, and now it's the issue solved. It's basically the same solution like we saw before for Google. Let's look here on this example. So my user A is starting to create a view, so he's opening a part and he wants to see additional things here. Maybe he wants to see what's on the splice connected here. Okay, additional information. Now he's interested here in this lamp. Okay, the lamp gets a connection over here, goes via an inliner, jumping another inliner, and finally arriving here on this ECU. So that's his content. Maybe he wants also change the layout for whatever reason. So move this a little bit here and here. And now he wants to share this with his colleague, and he can use now this new function of bookmark. He is creating a bookmark and transferring this bookmark to his colleague. And on the other side, opening this bookmark, we see the user B has exactly the same view, the same viewpoint like it was before. Also here, of course, this is not a static picture. This is a living real data model which can be also modified by this user. Now he can add content, he can modify the layout, whatever he wants to see. And of course also he is able now to create a bookmark and send it back to his colleague and having then the same visualization also on the user A side. Now that's a new technology implemented in the latest version of the connectivity browser, and this really gives great solution for the sharing. It's also a solution for storing digital views. For example, yesterday I was working here on the lamps, and I created here a specific view, content and a layout, everything what I wanted to see, and I want to use it today. So I was storing this view yesterday as a bookmark in a bookmark manager, and this bookmark management gives me now the chance that I or somebody else who has access to this management system is opening exactly this view again. So that's a very, very powerful functionality which opens a lot of benefits here in different use cases. So coming for the remaining time to some live examples, and we are just starting with the bookmarks. The bookmark here is starting with the bookmark manager of Google Chrome, where we are already in here. Lesezeichen is a German word for that. And there's a bookmark block diagram, and this is what we are just opening here with a double click on it. And the system is opening now directly at this viewpoint. And this view is now exactly the content and the layout as it was prepared. That means, for example, somebody was moving all the switches here to the left side for whatever reason and had this 90 degrees rotation. By the way, this is also a new diagram type we are supporting. In addition to the wiring and logical diagrams which we had before, we are also supporting now this kind of one-line diagram or block diagram. So this was an example with the integrated bookmark manager of Google Chrome here, for example. There are also external or third-party solutions like the Raindrop.io, which we see here now. I personally like this quite a lot because they have a nice structure management folder or collection structure, which gives me the chance here to organize my bookmarks. And they also have a graphical preview, which helps me in some cases to identify what I want to open. So let's start here with this example. It looks a very simple connectivity. It's just 3 boxes, 3 fuse relay boxes, which are connected here by virtual wire. So there's nothing exciting about that. The new functionality comes up if we are clicking here on one of these connection lines on these wires here in this specific case, and as soon we are clicking on one of them, we see the inner circuitry is open. So we have a visualization not only of the connectivity and the harness side, but also what's inside the boxes. And you see it's not only a visualization, it's also a highlighting. So we see exactly this wire goes here to the connector A pin 1, and then internally it's connecting here to the coil. The visualization of the inside connectivity can be done here like on the left with a single component view. On the right we show the complete fuse relay boxes overall elements, or here we are visualizing just the coils of all the relays, or in a different level here if we connect here then we see all the contacts, or in a depending on the connection also the fuse. So this connectivity of the boxes, the inside connectivity is generated on the fly by the selecting here of the wiring connectivity, the outside connectivity. And this helps now, of course, a lot to trace the signal flow not only from component to component, but from internal device to internal device. Prerequisite for this technology is, of course, that the source system has a model of the inner connectivity and it is exporting it. Coming to another example, here I'm just opening here another short design. It's a simple design for automotive seats. So we see this ECU as an X10, and we have 3 motors connected plus 1 switch. So I can open, of course, this connectivity, see what else is on the X3. I can look to different properties. Maybe you're familiar with this already. This is standard functionality of the connectivity browser. What is new, why I opened here this example, I want to show you this use case linked to 3D, because there are often the question, where is this unit in the vehicle, what is the location here, and for this, of course, it's a perfect way to visualize this directly in the 3D model. This can be done also on this web technology, on this cloud technology. In the meantime, there are powerful viewers, and here we are jumping in, generating directly this visualization, and in this visualization we see already this connector is selected here, and it's also selected in the tree. Of course, the 3D visualization gives always good information for all the physical or geometrical aspects. Where are the wires routed, where are the connectors located, etc., etc. And of course, it could be also a use case that I'm coming from a 3D and we want to see what is the connectivity. For example, we want to see what is the connectivity of this left connector here on this ECU, or this one. With a double click on this, we are opening a connectivity visualization exactly around this X11. So that means we have a round trip functionality is possible here to go to the 3D and coming back. Of course, I repeat, always this is an electrical design dynamic view with all the information. And of course, I could also use an object like a wire for getting here starting my round trip into the 3D world. Here, see where this wire routed, and I create out of this view here, in this case now without the mechanical parts, just see the routing from connector to connector, and all related elements are activated or selected here in the tree. So coming back, looking to another example, it's not only a vehicle industry, we also use the connectivity browser in the cabinet area for machinery industry. So what we see here is a schematic. It's a little bit different, mainly different because we have here symbols, complex SVG symbols in the boxes, in the blocks. This could be used as well. Of course, also here we have a lot of information in the background which are exported by the source system, and also here it's possible to transport the information of the location as a 3D model. Jumping and opening here a 3D model of the cabinet. The cabinet model was created by E3, and here we see all the selection that this component is already pre-selected. Also here in the 3D I can now browse around with the 3D functionality, and no surprise, of course, also here it's possible to jump back into a schematic and to visualize the connectivity around this object here. Here it's an 33Q1. See all the connectivity around here, which is interesting. So this is a functionality here in the cooperation between schematic and 3D. Looking to two more short examples. One functionality which we added here is this issue visualizing of block or modules. So for example, I'm just creating here, opening in a complete car design, some elements which I'm interested in. So I go to the splice, see, okay, what is connected to the splice, whatever. So I have a quite complex view now. And the question is, what is the assignment here into the harnesses? So I just can use this assignment into harnesses as a color visualization and say, okay, the front harness should be shown in blue, the main harness should be shown in brown, and then I get my schematic visualized and I see all elements here for the front harness, for the main harness. Of course, it's still an active element document or visualization, to say it more clear, and I can still use the normal function of exploring here my connectivity, and of course there are also other harnesses involved here. Then with this inliner I can also see the connection which is then on the rear harness. This visualization is not only working for harnesses, it's also working for other modules, like for functional modules, to use here color coding to identify here specific. It's a great function for troubleshooting or for checking to make sure that all the assignments in a digital models are correct. So this was Module Navigator as one new functionality. Another one I just want to mention here shortly. Of course, we are working with digital views, but there are sometimes use cases where it makes sense to create a document for the archive. That means to have something as a kind of, maybe for liability reasons, you need to have document in the archive. And there is a chance to create here outputs, PDF outputs. It could be done based on structures of modules, like here on the functional modules. It could be done for harnesses or also for ECU content. There are many kind of selections, like here I can select which functions I want to use to create here documents. I of course have things like the title page or frames around it, and then I could create here this PDF. Like I said, it's more for archive, it's not for the working document. For the working documents we are working online. Another function also just mentioned here with a few words. We have a new chance to visualize the difference between two designs. So I have a design version 1 and a design version 2. And the connectivity browser can load both and find out the difference between both and provide then also a visualization here, what was added, what was deleted, and so on, to give me a chance to identify complex changes. Unfortunately, we don't have the time to go in all the details here. I just want to give you a very short appetizer of the powerful functionalities which you have here in the connectivity browser. Coming back and going for a summary, I think connectivity browser is a part of a digital twin. It's a mandatory part of a digital twin strategy. And I hope you agree with my statement that the visualization of a digital connectivity of a wireless has never been that easy like we can do it here with the E3.Connectivity Browser. We are supporting different sources coming from E3, having legacy data from partners in any kind of digital format. So we are very flexible on this part as well. There are different applications available out of the box. Could be on cloud technology, could be as a Windows application. In addition, there is an API available which allows deep integration, and I think a very important integration is in the service field, the integration with the diagnostic system. I showed some of the new features like the hierarchical view, 3D link, or the permanent link, and I think this is a proof how additional functionality can create additional benefits. Thank you very much for joining this presentation and for participating on the Zuken Innovation World 21 in our digital forum here. As mentioned before, I'm going to open now the breakout session, and I hope to see and hear plenty of you and have an interesting discussion. Thank you. Bye-bye.